Okay, this time we're looking at the sum formula for geometric infinite. Here's our infinite symbol, and in this case we used it with decreasing r values only, and those values would be, so r would be less than 1, but it would be greater than 0. So we're looking at something that's a fraction, so this is a decreasing situation only, where your long range value will end up at 0. So something that will not change over time. So we have an explicit formula little cheater here, so we can pull some of our information out of this to address here. So a sub 1, I'm going to put in 1 for that. So that would look like 250, 250, and I'm going to use a decimal, 0.25, it's end of the 1. So that would be, I've already calculated that out, that would be, let me rewrite that in a different color so you can see it. That would be 62.5. Okay, so we have our r value, our a sub 1. This is a really straightforward equation, so the numbers will go in easily. I'm going to move my explicit formula because I got the information I needed out of there. I'm going to move this up so we can see what we're writing. Okay, so a sub 1 was 62.5, and then we have 1 minus r, and r in this case is a fraction. If it comes out nicely as a decimal, I would leave it as a decimal. If it doesn't come out nicely and it has a repeater, you probably want to use the fraction in your calculator to calculate this out. So when this gets calculated in the calculator, oops, infinite symbol, so we are approximately 83.3 repeating. So where did I get all this information again? I'm using the infinite sum formula, geometric infinite sum formula, and that looks like this. It's used in decreasing situations where the r value is less than 1 but greater than 0, so you're dealing with fractions here. So we have our infinite symbol. We know that we can use this because our r value is a fraction of 1/4, or 0.25 in this case. Multiplied it out, I got my a sub 1 value, was able to plug that in. My r value is found here because of our explicit formula, if you remember back. Plugged that in as well, did the calculation in the calculator, and came out with approximately 83.3. Give it a try. This is some fun.